Hi, my name is Glenn Weinreb, and today we're going to look at how to significantly reduce the cost of nuclear power with automated construction. Nuclear power plants typically require significant amounts of concrete and rebar, in part because they need to withstand attack from missiles and airplanes. In principle, these costs could be reduced by placing the reactor vessel underground inside a concrete-lined chamber surrounded by bedrock. Achieving this affordably would probably require the development of specialized machines that automate excavation, installation of concrete lining, and assembly of reactor components. And this might require a new transportation system that moves large and heavy loads from factory to site, an example of which is shown here. It typically costs more to build underground. However, this might not hold true for gas-cooled nuclear fission reactors that are built with custom machines. Traditional reactors are cooled with pressurized water. However, several instead use gas. Gas carries less heat per unit volume compared to water, and therefore gas-cooled reactor vessels are physically larger than their water-cooled counterparts. Consequently, their nuclear fuel is more spread out, which helps them not melt when not cooled. More specifically, in the event coolant is lost in a gas reactor, decay heat is moved via radiation to concrete chamber walls and then to bedrock. Alternatively, water-cooled reactors are dependent on external systems that must be protected against attack, and this drives up costs. A cost-effective underground approach would probably involve developing specialized machinery that excavates in bedrock and installs a concrete lining. Rebar assemblies could be prefabricated in a factory, transported to the site, lowered into the excavated cavity, and then filled with wet concrete. There are two primary methods for excavating bedrock: mechanical excavation and blasting. Blasting uses explosives to fracture rock, while mechanical excavation uses machinery to cut and remove material in a more controlled manner. Costs can vary significantly, reaching up to approximately $250 per cubic meter of rock. However, based on our calculations, this would cost less than 2% of total site costs. For details, click on the link in the description below. As noted previously, custom machines are needed to break rock, remove rock, install rebar, pour wet concrete, and install subassemblies. This would probably require a gantry crane-like system that lowers custom machines into an excavation, an example of which is shown here. We asked AI to render this. Okay, not bad for a computer. The primary functions of the containment structure are to withstand physical attacks and to contain radiation under pressure. To hold pressure, a metal dome could be bolted down close to the top, and to protect against attack, a cement block could be placed above it. Nuclear reactors require various support systems, including pumps, electrical power generators, monitoring instruments, control systems, and nuclear fuel storage. In theory, some of this could be housed in a separate equipment excavation, while the reactor vessel and heat exchangers are kept in a power excavation. Custom machines could excavate rectangular chambers and tunnels that lead to reactor components. Also, custom machines could install concrete linings to ensure wall integrity. Support systems could then be pre-assembled within factory-made metal enclosures that are transported to the site and installed as needed. To reduce costs, multiple power excavations could be positioned around a central equipment excavation, as shown here. A preliminary estimate finds this approach would consume 9 times less concrete per unit electricity than Vogel 4 and 26 times less concrete per unit electricity than Hinckley C. In other words, less concrete is needed when mission-critical infrastructure is kept close to gas-cooled reactors. For details, click on the link in the description below. The cost to automate construction would probably be small relative to costs typically associated with nuclear power. In other words, if we put R&D money in the right places, we should be able to get 24/7 green energy at a cost less than fossil fuel. For details on how this works financially, see video number 13. And for more climate solution videos, visit www.aplantosavetheplanet.org. Okay, that's it for me, and I'll talk to y'all real soon.